is a great man named Gauss who discovered this equation. In physics, there is a Chinese word how to test the unknown material. For example, if we got a magic stone from Mars, how we get to know what is this stone and what is the property of the stone? We are always begin from these 5 words. The first one in Chinese we say li, and in English that is the force, which means the mechanical property of something. Mechanical property. We may squeeze it, we hit it, or we stretch it to know the mechanical property of this stone. Then we come to 热, which means heat, or the more property. We may boil it, heat it, dry it. That is the more property. To find how it changes with an increase in temperature. Then 声, which means sound. Does it make sound? Does it transport sound? Is it can it vibrate? That is or the sound property of something. Then 光, which means light. How it changes under the light will the atoms in the stone change when being shutted by photon. Will it provide some light? Is it shining? Is it it will be or will not be heated when being put in the condition of a certain light. That is light property. And the finally, 电 electric magnetic. It is a conductor or not. And if it is a conductor, it is efficient or not efficient, then the metal arms, for example, iron or steel. 地、热、声、光、电 to test a material by force, by mechanical property, heat property, sound property, light property, and electromagnetic property. The Gauss's law is an interesting way to test the electric magnetic of one thing. It is still the stone from Mars. If we'd like to know the electric magnetic property of it, for example, if we want to know it is charged or not, it is charged or not, what can you do to measure it? First one, charge. And the second, how much charge? How to measure it? To know it is charged or not. How to measure it?
Measure that it can be charged.
Yes. How to do it?
You can use like to measure the resistance of it or other things.
Distance are bigger. So we can, for example, if I'd like to know the radius of it, we just measure with a ruler. And then if we want to know the temperature of it, we measure it with the temperature. And if we want to know the color of it, we just see. So how to know if it is charged?
Ocean. I think we need to know the time.
The time.
Yeah.
Why?
Because it will be firing from the mouse. Like if it is coming from the mouse to the Earth, we know the time. It just tell. So it just use it from the mouse to the Earth. Maybe it is just absorbed by gravitational acceleration.
So how about we define the time is from the beginning, and it is similar to the measurement. The same to the measurement. So it's in our uniform life, the electric magnetic field is not dependent on it. The time that depends on that influence the world is by the quantum that is far from our uniform life. So we can ignore the time. Of course, it will influence it, but it's very small. So in this case, we can ignore the time. To know it is charged or not, there is a very easier way, that is to take another charge point here. Then it is charged or not will be reflected by this charge as the detector, because if there is a force on it, it is charged. If there is no force on it, no matter where you put that charge around the stone, there is no force no force on the charge point, which means the stone is not charged. And the key.
But Laoshi, I think even friction can help us to know if it can be charged.
Okay.
I'm saying that maybe even friction.
Friction.
Yeah, friction maybe can help us to see if the property is charged or not charged.
You mean after the friction it can be charged?
Yeah, I think so.
Of course. Of course. And the thing is, if it, after friction it is charged, that is another situation. I will talk later. And before the friction, okay? Before the friction, we just to test it is charged or not. You just put a charge point here. If situation 1, there is a force to force the point away from the stone. What does that mean?
This means that there is impulsion.
Yes, it means that this stone is also a positive charge. How about another situation? There is the force that attracts the point to close to the stone.
It is minus.
Yes, which means the stone is negative charge. And as you said, after friction, it may have another additional charge on the surface of the stone. Of course, that is another electric magnetic property. After this, we can also do the test again. If it changes, and we got to know that the stone is further charged by negative or positive, both possible. So that is a test way. No matter what shape and what it looks like, that is useful, available test way. If the stone in this situation, one put the point charge as a detector around the stone we found. On the left, there is a force to force it away from the stone. However, on the right, there is a force to force it to be attracted by the stone. And in the middle of the stone, there is no force. Can this be possible?
Yes.
No.
Yeah.
How?
No, Roshan.
Yeah. That it means like there is 2 poles.
2 points.
Yeah, it means that there is 2 poles. Then
On
there
the
is
left
north and
part.
south.
Yes, the left part is a positive charge and the right is a negative charge. So that is a test way. And the Gauss's law is another simple way to measure an electric field. And we define a new parameter that is electric flux. Before we do the calculation of flux, we are going to see some situation of a books contain unknown amount of charge. As we talked about, if in the box there is a positive charge point, when we using a test charge outside the box, we will find the charge was forced to be away from the box, which means there is another positive charge in the box. Then, in this situation, the electric field that is through the box there's a many electric line of electric field. Outward flux. If the positive charge inside the books is double, the flux will be double 2. And when the positive charge was replaced by a negative charge, and which means in this situation there is a negative charge inside the box, and the flux will be opposite way, that is from the far away to the point to the negative charge. Again, we double the negative charge, the flux is double. There is a new definition. Quantity of flux. What we need to calculate is the overall flux. That is outward or inward the flux, which means the quantity of flux. And it is defined by the area times electric field. A times E. Situation 1. There is the electric field from the left to the right, and the vertical cross vertical to the surface. By using the definition, the area of it, we can do the times of S and E. this parameter means the quantity of flux, and it is defined by the conduct of area in the electric field. This new parameter is very important in the Gauss's law. It can be used to the calculation of charge for the electric field and for many things. That is a special situation. If the electric field is not vertical to the surface, there is some angle between the surface and the electric field. The quantity of electric flux is no longer equal to S times E, and the little field equals to another sin theta. What does that mean? Because if there is a uniform electric field from the left to the right, when we put a surface here, there will be in this situation 1, 2, 3, 4, 5, 6, 7, 8, and 9 flux that penetrate the surface. However, when there is an angle between the surface and the electric field, even though the length of this disk is the same, the flux that penetrate the surface will be different, and it is less than before. In a special situation, when that disk is turned to be parallel to the electric field, the quantity of flux that penetrate it will become 0. And that is in the situation of sin theta equals to 0. The sin theta, sin 0 equals to 0.
So Lordship, the long of the big surface, it's also make electric, like this quantity of flux. When the surface is big, then it becomes big. When surface is small, then it becomes small.
Yes. When the surface bigger, the quantity is bigger. When the surface is smaller, the quantities become less. So there's three things that influence the quantity of the flux. And the first one is the area of the surface. And the second one is the quantity of the electric field. And the second one is the direction of the electric field and the surface. The four influence the calculation of the quantity of electric flux. The cosine theta here is another angle. No matter you use here, or the sine theta here. That goes because sine theta equals to cosine theta. They are the same thing. No matter which one you use, just remember the angle before you do your answer of a certain question. If it is a non-uniform electric field and an arbitrary surface, we are back to the integral. We need to do to divide the surface into numerous parts and to do the integral. That it will be specialized by a certain question and it is unknown here. Okay, let's do some interesting questions here. Number one, calculate the magnitude of the flux of a constant electric field of 5 Newton per Coulomb. Electric field 5 Newton per Coulomb. In the x direction, through a rectangle with area 4 meters square in the x, y plane, which means the rectangle is with the location like this. So, can you give me an answer? What is the magnitude of the flux? First, the S, the value of it, 4. Electric field, 5. Then, theta. Does someone can give me an answer? A, B, C, or D? A, 0, Y. Y.
Yeah, it means maybe like the object is parallel to the magnetic field.
Not 0, not 0. And then you to the final answer is 0, which makes the sine theta 0. The sine theta is the angle between the surface and the electric field. As we said in the question, the electric field is in the x direction. In the x direction. And the rectangle is in the xy plane. XY plane. It's just like I draw here. And which means the surface of the rectangle is parallel to the electric field. And the electric field just comes through the rectangle and no flux will penetrate the rectangle. Therefore, the final magnitude or the quantity of the electric flux equals to 0. Or you can say because the sine theta, the angle between the rectangle and the electric field is 0. Then the question 2. Calculate the magnitude of the flux of a constant input figure 5 and in the z direction. Z. X, Y, Z. With the E in the Z direction. Z. Then draw a rectangle with an area 4 meters square in the XY plane. XY plane again. It is drawn and someone can give me an answer. D. D. D.
But we will need to calculate. I think we need to calculate it.
There's only one question because no matter the S or the E is known. The only unknown thing is the sine theta. Then can tell me the angle between the surface of the rectangle and the electric field. It is parallel or vertical? Somewhat vertical. Yes, because the z direction is vertical to the xy plane, which means the electric field is vertical to the xy plane, or the electric field is vertical to the rectangle. Therefore, it is with a 90 degree, and sine 90 equals to 1. So 4 times 5. That is the 20. So the final result is C. Not so difficult, huh? A disk with radius 0.1 meter is oriented with its normal unit vector end at an angle of 30 degrees to a uniform electric field E with magnitude of 2 times 10 triple 9 Newton per coulomb. Question 1. What is the electric flux through the disk? What is the electric flux through the disk? No problem. And the electric field is known by the question. That is 2 times 10 as we here.
Yes.
How about the area of the disk?
We have radius.
Pi r squared, right?
Yes.
And that is 0.01 pi. The angle between the surface and the electric field, the angle here, that will be 6 sine sine 60 equals to cosine 30. So no matter we use which one, it is also okay. And the final result is square root of 3 of 2. And we finish the calculation. You will got an answer of 54 Newton meter square per coulomb. And the question number 2. What is the flux through the disk if it is turned so that its normal is perpendicular to E? Even easier. Someone can give me an answer?
Sine it will be equal to 1. Because if it's perpendicular, it will have
Sine 0 or sine 90?
Yes.
90.
Yes.
So 1. The final result? Incorrect choice. Sine 0. Try again. What is the flux through the disk if its normal is parallel to E? Normal means the vector that is vertical to it.
Parallel to E.
Yes, when its normal is parallel to E, which means it is. So the right that in this case cosine is 90. So in this case the final result is 63. Okay, class over.
Still don't like it.